Now, petrol prices could reach a new record this year, according to the motoring organisation, the AA.
Petrol has become much more expensive over the past 10 years. In 2000, when motorists across the UK protested against rising prices and taxes, a litre of premium unleaded cost 75 pence.
And we're in the midst right now of a recovery that is starting to build up steam, and we don't want to reverse it. What I have also said about gas prices is that there is no silver bullet.
Surged to $4.61 this morning. That's the highest in the nation. Refinery and transmission problems are fueling the soaring prices. In some places, the price is closing in on $6. As Ben Tracy reports, the high prices are forcing some stations to close.
Mankind is facing a growing scarcity. Specifically, our natural reserves of crude oil. Oil is the only natural substance that can provide such large quantities of powerful, reliable energy for mankind's vast transportation network. However, our only reserve is dwindling fast. This means making solutions. One very promising solution comes in the form of algae. Recently, scientists have turned their curiosity into multi-million-dollar research contracts with many government entities and corporations. This short documentary will investigate the possibility of algae biofuels and their progress of integrating with our current transportation needs. With any new technology, its research costs are high and attract opponents. For example, they focus on algae's high demand for both land and water, or its astronomical $19,000 per acre development cost. Or specifically, when in late 2012 the US Navy demonstrated algae biofuel, it cost $27 per gallon. However, algae has many supporters. They highlight the fuel's unique ability to be carbon neutral, or the fact that it has the possibility to sell for just $3 per gallon, or finally, that it has the capability of fueling diesel and petrol vehicles, airplanes, and ships. Arizona State University's Polytechnic campus has a laboratory devoted to its research.
Algae are a promising alternative because, number one, they're very fast-growing organisms, and they produce a diversity of oils or lipids that can be converted to fuels. I'm Milton Sommerfeld, co-director of the Arizona Center for Algae Technology and Innovation. So the reality is they can be used for transportation fuels, like petroleum is. So you can make diesel, or gasoline, or aviation fuel out of algae oil. So the process involves, again, the cultivation, production, harvesting, getting the cells out of the water in most cases, or at least reducing the amount of water, and then converting that algae oil, or taking it out of the cell, and then ultimately converting it to whatever product you're interested in. If it happens to be diesel, that's a fairly simple process. The fuels that come from the algae typically do burn cleaner. They're typically less nitrogen or NOx and less SOx or sulfur that's emitted when that fuel is burned. If you talk about the amount of land area that's required for growing algae for this, it's much less than it would be for any other crop plant that you would apply for oil or for any other product like that. But with the algae, what you're doing is recirculating the carbon dioxide. In other words, they take carbon dioxide out of the air, convert that carbon dioxide to organic molecules, to the oils. And so when it's burned, you're simply re-emitting the carbon dioxide that was taken up by the algae when they produced the oil. The reality is it's oil. And so you can refine it to make, in a sense, whatever you want to make out of it in terms of fuels. And what's so great about this is that the algae represents a renewable source of petroleum.
Algae biofuels, then, are at a significant crossroad. Its research could unlock the ability to allow mankind a fuel that is carbon neutral, cleaner burning, cheaper, and safer to produce than our current reserves of petroleum and diesel. However, the fuel is far from being readily available. It lacks the infrastructure to become a reliable solution. That's why ASU and other research firms are so vitally important in order to explore every avenue of research. Otherwise, this fuel will be nothing more than a faint blip on the timeline of sustainable energy. So then, what happens now will determine how significantly the renewable energy landscape can be shifted to include these revolutionary ideas. Already, both big energy companies and small research firms have started brainstorming on how to solve the impending energy crisis, because without a dramatic change to mankind's energy habits, there won't be any fuel left.